bugünkü oturum başkanlığını ben yapacağım. Bir değişiklik var programımızda. Güncel program üzerinden hareket edeceğiz. Şu an itibariyle 6 tane sunum gözüküyor programımızda. 15'er dakika konuşmacılara verelim, 5 dakika soru cevap için zaman ayıralım. Sonrasında da toplu bir resim çekilecek herhalde. Konuşmacılardan eğer acil bir programları yoksa oturumun sonuna kadar kalmalarını rica ediyorum bu açıdan. Evet, ilk konuşmayı Geodesign, CBS'nin geleceği başlığıyla Fred Barış Ens yapacak ama biraz evvel yemekte gördüm. İlk de ona söz vermek istiyorum çünkü uçakları varmış, uçağa yetişeceklermiş, çıkacaklar hemen. Olmadı onu atlayalım o zaman hızlıca. Su kaynakları yönetiminde CBS ve oyun teorisi. Narges Ganjali ve Caner Güney. Onların sunumlarını alalım. Buradalar mı kendileri? Evet. Programda biraz geriye kaldık. Mümkün olduğunca hızlıca toparlayabilirseniz sevinirim.
Hello everybody, welcome to my presentation. I am Narges, PhD candidate of Geographical Information Technology at Istanbul Technical University. Pardon, I'm going to talk about using GIS and game theory to improve water resources management. First of all, I'm going to start with a general introduction of the major components touched by this cross-disciplinary topic. What is water resources? When we use water resources, we are specifically referencing to sources of water that are potentially useful in agricultural, industrial, household, recreational, and environmental activities. As you can see in the chart, only 3% of the earth water is fresh water. About 69% of this is 3% is in ice caps. Pardon. And glaciers, while groundwater constitutes another 30%, which leaves all lakes, rivers, and swamps combined to only account for a small fraction, which is something around 0.3% of the Earth's total freshwater reserves. What is water resource management? Water is a nomadic resource flowing through space and time across landscape and through economies. All benefits from it, but few understand how it is actually managed. The management of water is not merely a technical issue. It requires a mix of measures, including governmental policy, price controls, and incentive, as well as a related infrastructure and physical installations. The term water management covers a variety of activities and disciplines that can be divided into 3 categories, such as managing the resource, managing water services, and managing the trade-off needed to balance supply and demand. Water has historically been a source of tension and a factor in conflicts. Water conflicts arise for many reasons, including territorial disputes, battles for resource, and strategic advantage. These conflicts occur over both freshwater and saltwater, and both between and within nations. However, conflicts occur mostly over freshwater because freshwater resources are necessary yet limited. In a water conflict, different interest groups or individuals can be modeled as decision makers, where each decision maker can make choices and the combined choices of all players together determine the possible outcomes of the conflict. Instead of that moving, decision makers also may decide to cooperate or form coalitions leading to a state of equilibrium or Pareto optimal outcomes. And what is game theory? Game theory is essentially the mathematical study of competition and cooperation. It illustrates how strategic interactions among players results in overall outcomes with respect to the preferences of these players. Games are defined mathematical objects consisting of a set of players, a set of strategies available to them, and specifications of players' strategies. Pardon. Players of payoffs for each combination of such strategies. Game theory can be used to predict how people behave following their own interests in a conflict scenario. And in a typical game, decision makers who are players with their own goals try to outsmart one another by anticipating each other's decision. The game is resolved as a consequence of the players' decisions and analyze the strategies players use to maximize their payoffs. A solution to a game prescribes this, decisions the decision makers might make and describe the game's outcome. Nash Equilibrium. Nash Equilibrium is the solution to a game in which an individual can receive no incremental benefit from changing action, assuming other players remain constant in their strategies. A game may have multiple Nash equilibria or none at all. Nash equilibrium is a fundamental concept in the theory of games and the most widely used method of predicting the outcome of a strategic interaction in the social sciences. A game consists of three elements. One, a set of players, a set of actions.
Last 5 minutes.
Oh, okay. Anyway, we must do monitoring the change for a Nash equilibrium. In order to Nash equilibrium, we must do monitoring the changes of players' behaviors, situation, and strategies to update the equilibrium. Game theory. Why we choose game theory? Game theory problems are often multi-criteria, multi-decision maker problems. To solve such problems by conventional optimization methods, usually the problem is converted ultimately to a single decision maker problem with a single composite objective for the whole system, such as an overall economic or social welfare function or a weighted constraint multi-objective function. Game theory can help provide planning, policy, and design insights that would be unavailable from other traditional system engineering methods. Another advantage of game theory over traditional quantitative simulation and optimization methods is its ability to simulate different aspects of a conflict, incorporate various characteristics of the problem, and predict the possible resolutions in absence of quantitative payoff information. Game theory application in water resource literature covers a range of water resource problem location, solution methods, analysis types, and classifications. Well, in this hypothetical water conflict example game, we assume two littoral countries share a lake. Each country has one river flowing into the lake. As a result of high evaporation and a reduction in seasonal flow of the two rivers from upstream rainfall use, the lake is drying up, becoming salty, and its ecosystem is deteriorating. For the lake and its ecosystem to survive, both countries must increase water releases to the lake by the specific amounts, let's say 30%. Because of high evaporation and increase in flow, only by one country cannot solve the problem. The payoff of each country is the environmental benefit from increasing the inflow to the lake minus the revenue lost from decreasing upstream consumptive use. In both countries, reduced consumptive, consumptive reduction use upstream and increase, sorry for that. Excuse me. If both countries reduce consumptive use upstream and increase releases to the lake, the environmental benefits will exceed the revenue losses from reduced upstream consumption. However, if only one country increase its release to the lake's problem is partially solved. The environmental benefits will be minimal, and that country's payoff will decrease from revenue losses from decreased upstream use. The game has two equilibria here. The game has two equilibria: cooperative and non-cooperative. Increase and increase is cooperative. Both of them increase their release, and when none of them increase the
last 2 minutes.
All right.
Could you please come to results maybe?
All right. I was mentioned the benefits of MCDM, multi-criteria models, decision models, and the multi-attributes and multi-objective decision methods are two categories of multi-criteria decision-making models, and GIS components is not, there is no need to talk about it, and decision support systems. A spatial decision support system is a computer-based system that combines conventional data, spatially referenced data, and information, and decision logic as a tool for assigning a human decision maker. It usually includes a user interface for communicating with the decision maker. SDSS does not actually make a decision, but instead assists and analyzing data and presents process information in a form that is friendly to the decision maker. Decision support systems are increasingly being combined with geographic information systems to form a hybrid type of decision support tool known as a spatial decision support system. Such systems combine the data and logic of a DSS with the powerful spatial referencing and spatial analytic capabilities of a GIS to form a new system that is even more valuable than some of its parts. SDSS tools can be used to assist in making effective decisions for many kinds of problem sets and information domain, including natural resource management, business, healthcare, emergency management, and many others. All in all, the combination of game theory, water resources management, and GIS can be a powerful applied model in water studies. However, due to its complexity, the combination is still neglected in studies of water resources. GIS game theory combination can be a positive enhancement to improving the quality of analysis across a widespread and complex range of problem set and ultimately leading to comprehensive and accurate decisions. And thank you for your attention.
Thank you very much. I want to keep you on the stage for the questions. But first of all, I want to invite Fred to make his presentation.
All right.
Okay, thank you.